The facts about time travel, science, theories, and possibilities. Time travel has been one of the most fascinating concepts in science fiction and theoretical physics. The idea of moving through time in a manner different from our standard experience has been explored in countless books, films, and scientific discussions. Is time travel possible, and if so, how would it work? This video will take a deep dive into the theories, scientific foundations, paradoxes, and potential real-world applications of time travel, separating fact from fiction and exploring the profound implications for our understanding of the universe. The concept of time travel. Time travel refers to the ability to move between different points in time just as one moves through space. In our daily experience, time moves in one direction, from the past to the future at a constant rate. However, various scientific theories suggest that time could be manipulated, slowed down, or even reversed under specific circumstances. These ideas have led to serious scientific debate about the nature of time itself and whether it is something we can navigate like the dimensions of space. Understanding time through physics. To understand time travel, it is essential to first understand time as described by physics. Classical Newtonian physics treated time as absolute and unchanging, a background against which events occurred. However, Albert Einstein's theories of relativity radically changed this perception. According to special relativity, time is not absolute but is instead relative to the observer's frame of reference. This concept, known as time dilation, suggests that time moves slower for objects traveling at speeds close to the speed of light. The twin paradox. One of the most famous thought experiments demonstrating time dilation is the twin paradox. If one twin were to travel near the speed of light on a spaceship while the other remained on Earth, the traveling twin would experience time more slowly. Upon returning to Earth, the traveling twin would have aged significantly less than their sibling, illustrating the real effects of relativistic time travel. Time travel in general relativity. Einstein's general theory of relativity expands on this concept by suggesting that gravity itself can affect the passage of time. Massive objects like stars and black holes create gravitational fields that warp space-time. According to this theory, the stronger the gravitational field, the slower time moves for an observer within it. This means that an object orbiting close to a black hole would experience time more slowly than a distant observer, a phenomenon known as gravitational time dilation. Wormholes and time travel. One of the most popular theoretical methods for time travel involves wormholes, also called Einstein-Rosen bridges. A wormhole is a hypothetical tunnel connecting two distant points in spacetime. If such a structure were stable and traversable, it could potentially allow for movement between different time periods. However, the existence of wormholes remains purely theoretical, and many scientists believe they would require exotic matter with negative energy density to remain open. Time loops and closed time-like curves. Another potential mechanism for time travel is the concept of closed time-like curves. These are theoretical paths in space-time that loop back on themselves, allowing an object to return to its own past. Some solutions in general relativity suggest that such curves could exist under extreme conditions, such as within a rotating black hole or a hypothetical cosmic string. However, whether such curves could be used for practical time travel remains a matter of scientific debate. The grandfather paradox and other time travel paradoxes. One of the most significant challenges to the concept of time travel is the problem of paradoxes. The most famous example is the grandfather paradox, in which a time traveler goes back in time and prevents their own grandfather from meeting their grandmother. If this were to happen, the traveler would never be born, leading to a contradiction. Other paradoxes include the bootstrap paradox, in which an object or piece of information is passed back in time without an origin, seemingly existing in a loop. Possible resolutions to time paradoxes. Various theories attempt to resolve these paradoxes. One suggestion is the self-consistency principle, proposed by physicist Igor Novikov, which states that any action taken by a time traveler was always part of history and cannot change past events. Another idea is the many worlds interpretation of quantum mechanics, which suggests that time travel would create parallel timelines, preventing contradictions by splitting reality into multiple branches. Time travel in science fiction and popular culture. Time travel has been a staple of science fiction for over a century, inspiring countless stories and theories. Classic works like H. Wells' The Time Machine, the Back to the Future trilogy, and Doctor Who have shaped popular ideas about time travel. These stories often explore the consequences of altering the past or navigating future events, providing both entertainment and philosophical reflection on free will and destiny. Experimental evidence and future possibilities. While time travel remains theoretical, some scientific experiments have observed related effects. Atomic clocks placed on high-speed jets or in strong gravitational fields have recorded time dilation in action. Scientists at the Large Hadron Collider have also observed particles called muons decaying at slower rates when moving at high velocities, consistent with special relativity. While these effects do not allow for human time travel, they demonstrate that manipulating time is indeed possible within the laws of physics. Future breakthroughs in physics could provide new insights into the nature of time. Advanced technologies like quantum computing and high-energy particle research may lead to unexpected discoveries about space-time manipulation. If practical time travel ever becomes possible, it could revolutionize our understanding of the universe and open up unprecedented Time travel remains one of the most intriguing and mysterious subjects in both science and science fiction. While current physics provides mechanisms for limited forms of time travel, significant challenges remain before humanity could traverse time as easily as space. Whether through wormholes, closed time-like curves, or future quantum discoveries, the pursuit of time travel continues to push the boundaries of our understanding of reality. Until then, we remain travelers moving forward through time at the pace of 1 second per second, eagerly awaiting the next great breakthrough that could change everything. Extended discussion on the philosophical and ethical implications of time travel. If time travel were to become possible, profound philosophical and ethical questions would arise. Would changing the past be ethical? And what would be the consequences of altering significant historical events? Would individuals have the right to change their personal pasts, correcting mistakes or reversing tragedies? How would society regulate the use of time travel, preventing its misuse or exploitation? These questions invite deep philosophical discourse on human agency, free will, and moral responsibility. Another important consideration is the potential cultural and social impact of time travel. How would our understanding of history change if direct observation or alteration of past events were possible? Would time travelers influence key moments in history to shape a better future, or would unintended consequences create new problems? These concerns highlight the importance of caution, regulation, and responsibility in the pursuit of time travel technology.